Mobile Media presents All About Atmosphere, the information you need when you need it. Have you ever wondered how a space shuttle or satellite can orbit the Earth without falling? Or what flying in an airplane and mountain climbing have in common? Have you ever wondered what a shooting star is? How we can hear people on the radio? Or why we need to wear sunscreen? All of these questions have one thing in common: atmosphere. An atmosphere is a layer or a set of layers of gases surrounding a planet that is held in place by gravity. So basically, planets are wrapped in a blanket of air. The air is pulled towards the planet because of gravity. The atmosphere on Mars is so thin that the surface temperature is an average of negative 83 degrees Fahrenheit. The atmosphere on Venus is so thick that it has the opposite effect. It has created so much heat that its oceans have boiled away. Saturn's atmosphere has rings of rocks orbiting. It can even rain diamonds in Jupiter's atmosphere. Our atmosphere on Earth is extra special, though, because it is made up of the perfect ingredients for life to exist. Without the atmosphere, we would not be able to breathe, and we would likely freeze to death. As we travel from the Earth's surface to space, the air is less dense. Remember that gravity is pulling the air inward towards the Earth. About 3/4 of all the air is compressed into the troposphere, which is just the first layer of the atmosphere. This is one reason why we can breathe easily at Earth's surface, but astronauts need a special suit with oxygen when they are in space. Something else you need to know first is that the Earth is receiving constant solar radiation from the sun. You might think that how hot it is on a planet is determined by how close it is to the sun, but that is only part of the reason. Let's take a look at the famous thin blue line that surrounds the Earth and that you can see from space. The blue that we see is the first layer of the atmosphere called the troposphere. Troposphere means change. This layer of the atmosphere has a lot of changes that occur within it. This layer extends to about 6 miles above the Earth's surface where you're standing, which doesn't sound far when you're driving in a car, but that is actually equivalent to stacking about 209 Statue of Liberties on top of each other. That's right, all clouds, rain, snow, and thunder happen in this layer. It is the only layer that most of us will ever see or experience. As we know, the weather is always changing and moving. The clouds we see today could contain water droplets from thousands of miles away the day before. One day the weather can be beautiful, and the next it can be crummy. This is why the troposphere is called the layer of change. Now picture yourself climbing a mountain. As you climb higher and higher, the air becomes thinner and thinner. You would need an oxygen tank to reach the top of Mount Everest. This change in air pressure and density is also the reason why your ears pop when you fly or drive up a mountain. The temperature also changes as you rise up in the troposphere. Remember that solar radiation is reaching the Earth from space. Think of the Earth as a huge rock. The rock is being heated by the sun. If you found a rock on the road on a hot summer day and picked it up, it would feel very hot.
Ouch!
But if you put the rock down and hold your hand away from the rock, you cannot feel the heat from the rock. That's because you're distancing yourself from the rock that is being heated by the sun. The same concept happens in the troposphere. As we get farther from the surface of the Earth, we feel cooler temperatures. The Earth is absorbing solar radiation, and as we climb a mountain or fly up high, the temperatures get colder. This graph shows that the temperatures get colder as you go higher up. That air is made up mostly of nitrogen, then oxygen, and the rest, 1%, is made up of gases like water vapor and carbon dioxide. That little amount of water vapor is what makes up all of the weather we experience. The next layer above the troposphere is the stratosphere. It extends to about 31 miles above the Earth's surface. Strato means layered. So this has the layered layer. This makes sense though, I promise, because it does have a sublayer or mini layer within it called the ozone layer. Ozone is pretty amazing stuff. It's a special form of oxygen gas. The oxygen we breathe is O2. which means that it is a molecule made up of 2 oxygen atoms attached together. But ozone is O3, which means that it is a molecule made of 3 oxygen atoms. This ozone molecule is actually highly toxic to us, and we cannot breathe it. It does protect us, though. It protects us by trapping harmful ultraviolet rays from the sun, which means it acts like sunscreen for the Earth. Some of the solar radiation is harmful to us, and this layer of ozone in the stratosphere traps a lot of it so that it does not reach the Earth. Now, this trapped ultraviolet energy is heat, so this part of the stratosphere, where the ozone is located near the top, is warmer than the rest of the layer. That is why the temperature rises. Next, we have made it to the middle, the mesosphere. Meso means middle, and that's exactly why this layer is called the mesosphere. It extends to about 53 miles above the Earth's surface. It's special because it has the coldest temperatures of all the layers. And that's because it's getting farther from the warmth of the ozone layer in the stratosphere. Meteors that come hurling towards the Earth often vaporize here too, which causes shooting stars. This happens because even though the air is very thin here, there are enough air particles to cause friction with the speeding meteors. That friction causes heat that vaporizes the meteor and disintegrates it. The next layer in the atmosphere is the thermosphere. Therm means heat, and this layer is the hottest layer with temperatures that reach up to 3,600 degrees Fahrenheit. The air is extremely thin in this layer, so even though the air here absorbs the highest energy solar radiation, which causes the temperature to be so high, you would actually freeze to death in this layer because your body requires the movement or heat energy from the air around you to transfer to the heat of your body. But in this layer, the air is so thin and spread apart that there would never be enough warm air near your body to warm you. This layer also contains a sublayer called the ionosphere, which is a section of charged particles from the sun. This charged atmospheric gas allows for radio waves to bounce back to the Earth once they are sent up from a station. When charged particles from the sun strike atoms in Earth's atmosphere, they cause electrons in the atoms to move to a higher energy state. When the electrons drop back to a lower energy state, they release a photon, light. This process creates the beautiful aurora borealis, or northern lights. You can see these beautiful dancing lights in locations like Alaska or areas near the North Pole. The last but not least layer of the atmosphere is the exosphere. Exo means outer, and that is exactly what this layer is, the outer layer. It just kind of gradually dissolves into outer space. This is where space shuttles and satellites orbit our planet, because there's just enough gravitational pull to keep them in orbit, but not enough to pull them back in towards the Earth. So to summarize, there are 5 layers of Earth's atmosphere that decrease in air pressure as you leave Earth's surface because there is less gravitational pull the farther away you get. The troposphere is where we live and breathe.
It gets colder as you go up because you're getting away from the hot rock Earth.
It means change because it is where all the ever-changing weather occurs. Stratosphere is next and means the layered layer because it contains the sub-ozone layer. The ozone layer traps harmful UV radiation from the sun, which warms the top of the stratosphere. The mesosphere is in the middle and burns up meteors. It also has the coldest temperatures. The thermosphere means heat layer, and it has the hottest temperatures, as well as electrically charged particles in the ionosphere that allow for radio signals to be sent back to Earth and for the beautiful northern lights to dance across the sky. And lastly, the exosphere, or outer layer, that extends to outer space. It is where space shuttles and satellites can orbit the Earth without being pulled back towards the surface. Thanks for watching.